Hey everyone, and welcome. Today we're diving into a problem that, let's be honest, drives all of us crazy in Python, especially in the MLOps world, dependency chaos. We're going to look at a pretty cool new tool called UV that promises to bring some much-needed sanity and clarity back to our projects.
You know the feeling, right? You've spent weeks, maybe months, getting a model just right. You're finally ready to push it to production, and boom, it all falls apart. And the culprit? It's almost always some tiny, unexpected update to a package you didn't even know you were using. That, my friends, is dependency hell, and it's a total nightmare when you're trying to build reliable AI systems.
So what's really going on here? What's the root cause of all this pain? Well, it boils down to something we can call the dependency dilemma. See, your project isn't just the packages you explicitly install, like pandas or scikit-learn. Nope. Each of those libraries has its own dependencies, and those have their own, and so on, creating this huge, tangled, invisible web. Trying to keep all that straight by hand, it's a recipe for version conflicts and the classic, dreaded, but it works on my machine problem. But what if there was a better way? What if a single, elegant tool could just handle all of this complexity for you? Well, that tool is here. Let's meet UV.
Now, the key thing to understand is that UV isn't just another pip. It's a completely unified, all-in-one system. It handles creating your virtual environments, installing packages, sorting out all those complex dependencies, and locking everything down so your builds are always the same. Plus, it's written in Rust, which means it is wicked fast.
And just look at the difference in your workflow. We're all used to that three-step dance, right? Create the venv, then activate it, then finally pip install from a requirements file. With UV, that whole mess becomes just two commands: UV init to set up your project and UV sync to install everything. That's it. It's so much cleaner. These features basically give you MLOps superpowers. Blazing fast means your CI/CD pipelines finish in a fraction of the time. A unified interface means there's less stuff for you and your team to learn and manage. But that advanced resolver and the built-in lock file, that is your golden ticket. That's what gives you stable, reproducible deployments, which is absolutely non-negotiable for production. Okay, so we've covered the what. Now let's get practical and dive into the how. How do you actually get a project up and running with UV? Turns out it takes just a few seconds. It really is this simple two-step process. First, in your project folder, you just run uv init. That creates a file called pyproject.toml. Then you run uv sync. This command reads that file, automatically creates a virtual environment for you, installs all the necessary dependencies, and this is the magic part, generates that critical lock file. And you're done. This is a really important principle in modern Python. Instead of juggling a requirements.txt file, a setup.py file, maybe some other config files, everything now lives in one place, your pyproject.toml. It becomes the single source of truth for your entire project. It's clean, it's simple, and it's the modern standard.
All right, so your project is all set up, but projects evolve, right? You're going to need to add tools for testing, for linting, for all sorts of things. Let's look at how UV helps you master your dependencies as your project grows up.
This is a super critical distinction if you're building production-grade software. Think of it like this. Your main dependencies are the actual parts of the car, the engine, the wheels. The car literally can't run without them. Your development dependencies, on the other hand, are the tools in your workshop, the wrenches, the diagnostic computers. You need them to build and fix the car, but you don't ship them inside the car. And here's how that looks in practice. Your main dependencies, things like pandas or MLflow, are what your model needs to actually run in production. You add those with a simple UV add. But your development tools, like pytest for running tests or rough for linting your code, you add those with the -dev flag. Making this distinction is the key to keeping your final production container lean, clean, and way more secure. So if your machine learning app needs pandas to handle data and MLflow to track experiments, you just run this one command. UV automatically updates your pyproject.toml and makes sure everything's in sync. It's that easy. And when you need to add your testing framework, it's the same simple command. You just tack on that dev flag. This basically tells UV, hey, I need this tool to work on my project, but don't you dare bundle it up when we ship to production. It's just a really elegant way to keep things organized. Okay, let's talk about what is arguably the single most important feature for any serious MLOps workflow. I'm talking about the lock file. This thing is your ultimate safety net. It's what makes true reproducibility possible. The best way to think about this is like an instruction versus a blueprint.
Your pyproject.toml file gives a general instruction. It says something like, hey, I need pandas version 2.2 or newer. But the uv.lock file, that's the exact blueprint. It says, for this build, right now, we are using precisely pandas version 2.2.3. And it does that for every single dependency and subdependency in the entire project. This lock file is what guarantees that your environment is deterministic. It is 100% reproducible. Every single developer on your team, every build server in your CI/CD pipeline will install the exact same versions of every single package. Every single time. And this is how you kill that classic painful, it works on my machine problem. For good. This is how you level up from just scripting to doing professional, reliable software engineering. It's the foundation for stable, predictable deployments. And as a quick little bonus, UV even makes running your scripts easier. You can forget about manually activating your virtual environment. You just put UV run in front of your command, and it automatically runs it inside the correct, managed environment. It's a small thing, but it removes one more little step where things can go wrong. And if you're working in a bigger company, you might be wondering, is this ready for prime time? And the answer is yes. UV is totally enterprise ready. It can connect securely to private package repositories, so you can manage all your internal packages right alongside the public ones and configure everything from one safe place. So I'll just leave you with this final thought. As data scientists and ML engineers, we're building these incredible state-of-the-art models with cutting-edge algorithms. So shouldn't our development tools and our environment be state-of-the-art too? Moving to a modern workflow with a tool like UV isn't just a minor improvement. It's a really important step in professionalizing what we do.